Hello and welcome to another video. In this video, we're going to be talking about the partial pressure of hemoglobin in this P50 chart that you may have seen before. So just to start off explaining what we're looking at, here we're looking at the percent saturation of hemoglobin, and down here we're looking at the partial pressure of oxygen. So this point is considered our P50, where hemoglobin is 50% saturated. And as you can see, it has a sigmoidal shape, which just means it looks like an S. And the reason is because hemoglobin and oxygen undergo something called cooperative binding or positive cooperativity, which means that with every oxygen that binds hemoglobin, the affinity for oxygen increases. And that just means that with every hemoglobin that's bound to oxygen, the affinity for oxygen increases. So we have higher affinity here than we do here because there's more oxygen bound. And it's almost acting as if it's incentivizing the hemoglobin to bind more oxygen. And so down here, we start with hemoglobin saturation being at 0. And this is the taut form. And in the taut form, hemoglobin is in a tight position. That's how I think of it. It's like really tight. And so it doesn't have a lot of room for oxygen to bind to it. And for that reason, the saturation is low because it would be kind of like in this position. Let's say this would be more of like a taut form where the spaces for oxygen to bind, they're not relaxed, so they're not open to accepting more oxygen. So the affinity is lower, and they call that in the taut form. And as you go up the chart and come up here, you reach the R form, which is the relaxed form. And here hemoglobin is relaxed, and so it's able to bind more oxygen easier. So this could maybe be an example of it being in the relaxed form. And in the relaxed form, like we said, we have more oxygen binding because there's more space for oxygen to bind. And here there's less oxygen binding because there's not enough room for oxygen to bind. And then you have several things that can affect this, the way this chart works, and the percent saturation of hemoglobin. A right shift in the graph could happen for several reasons. One of the mnemonics that I like to use is called cadets. And that stands for elevated CO2, elevated acidity, 2,3 BPG or DTG, exercise, elevated temperature, and sickle cell. Sickle cell anemia would be the S. And these things cause a right shift in the graph, meaning that hemoglobin spends more time in the taut form before it reaches its P50. So the affinity of oxygen with a right shift is going to go down. For example, with our fetal hemoglobin, which if you remember is alpha 2, delta 2 in our anemia videos, the left shift, that makes it where we spend less time in this taut form and we reach the P50 sooner. So it actually increases the affinity of oxygen. And that's basically everything you need to know on the P50 chart and how to read it.